welcome to the podcast of the European Young Chemists Network, EYCN. My name is Mark Carrada, and welcome to our new series. In this series, we interview the winners of the prestigious European Young Chemists Award 2020 to discuss with them their research and also ask them for advice for other young chemists. Today, we are talking about thin films that have antimicrobial properties and how they are synthesized, analyzed, and applied on various substances. To start us off, we have our Belgium delegate Nathan Carpentier interviewing the gold medal winner at the early career research level, Dr. Chiara Sportelli. Dr. Sportelli graduated in chemistry at the University of Bari in 2012, studying the synthesis and characterization of zinc monoxide antimicrobials. Her work was awarded as the best Italian master thesis in analytical chemistry of 2012. From 2013 to 2016, she accomplished her PhD studies in chemistry of innovative materials at the University of Bari and Ulm University, working on the development, characterization, and analytical application of new nanostructured materials and nanocomposites. This work during her PhD was awarded with 4 individual awards. After several postdoc fellowships, she recently became a non-tenured assistant professor in analytical chemistry at the University of Bari. She has had 10 years of experience in the synthesis and analytical characterization of metal nanoparticles, polymers, and nanostructured hybrid materials with antimicrobial properties. Her research mainly focuses on the use of combined analytical techniques for understanding microbial contamination, eradication, and fighting through controlled ionic release. And with that, I pass you over to Mr. Nathan Carpentier and Dr. Chiara Sportelli.
Hello, Chiara, and hello, listeners from this EYCN podcast. So I welcome today Chiara, who was a winner of the Young Chemist Award. And I will start with first a small introductory question. So what actually motivated you to go into chemistry and the analysis of microbial properties of various substances?
Good afternoon, everybody. So first I want to say that since when I was a child, science and chemistry always fascinating me. And during my master courses, I decided to specialize in analytical chemistry and in particular into the advanced characterization of nanomaterials. To me, the most interesting application of nanomaterial is the one as antimicrobial. That's why I decided to join the research group of Professor Cioppi and pursue this topic. Antimicrobial resistance is a serious healthcare problem and is costing many lives around the world. So discovering new routes to fight microbial infection is of extreme importance and in principle it could help saving many lives.
Okay, so your research yourself is about making the nanomaterial films, so for making antimicrobial films. But what actually is the real application you envisage with your research?
So these antimicrobial thin films already find application in many different fields, from textile and nonwoven modification, mainly for automotive industry and nosocomial usage, but also for food packaging. Recently we published some research papers about food packaging for fruit salads, mozzarella cheese, and so on.
Okay, so maybe to make the listeners a bit more familiar with your research itself. So actually you're making, as already mentioned, antimicrobial films. So you do this by having a spacer, and on this spacer you are sputtering 2 type of materials. Can you explain something more about this?
Yeah, so basically all these thin films are deposited by ion beam sputtering. So we have an ion beam which is hitting 2 targets, one made of Teflon and the other one is made, in this case, of silver. So the laser beam do not interact with the substrate, and this beam target interaction generates cluster, which then deposit onto the desired substrate in a vacuum chamber. There are no specific requirements for the surface to be coated. We sputtered many different material, from silicone slides to real textiles, plastic, foams for air conditioning, and so on. In most of the cases, these films are extremely stable. In fact, it's not possible to remove the thin film from the treated surface because these coatings are extremely stable. When possible, the only way to clean the surface is to chemical polishing it with for sandpaper or things like that.
So you can really coat every material. If you want to have packaging material, you can coat it directly on the packaging.
Yeah, we coated plastic boxes for food or bags for cheese and things like that. Yeah, so basically every kind of material.
Well, that's very interesting indeed. But for example, the food packaging, it's an application that's used for something that can be thrown away. And most of the things are recycled, of course, or we hope are recycled. But imagine that recycling process is not that good or people throw it in environment. Will this give problems to the environment? Because I can imagine you're using Teflon-based materials, which are quite stable, and also some metal parts, which are harmful for the environment, I guess. Can you comment maybe on this part?
Well, you're right. These two materials, so silver and Teflon, are not the most eco-friendly material we can imagine. However, we should consider that we are only talking about 150 nanometer thick coating. So there is a very small amount of material which is used to confer antimicrobial properties to surfaces. So we can generally state that, yeah, for sure these two are not eco-friendly material, but the quantity involved is such low because we can cover with a small amount of metal and non-green plastic a very large quantity of surface. Now we are currently working on the development of new composites with biodegradable polymer matrices like polyethylene oxide, polylactic acid, and also with less toxic metals like copper, zinc oxide, and so on.
Okay, great. Other possible applications I'm thinking of are, for example, because it's antimicrobial, wound dressing, for example. I think that also might be a possible application. But can you maybe explain, because antimicrobial is toxic for bacteria, I guess, and fungi mainly. But how can you explain that these layers or films are toxic for those organisms and not for the human cells then?
We fully characterize from a spectroscopic point of view these materials, and we can state confidentially that there is absence of silver fluoride, which can be toxic for both human and environments. And first, there is no entire nanoparticle release when this material is put in contact with some liquids. So we all know that entire nanoparticle can generate a nanotoxic effect because they can enter the Delmar and the hematoencephalic barriers and can accumulate in many organs into the body. Moreover, considering a perspective application of this thin film for the treatments of wound dressing and other textiles, the absence of silver fluoride and other toxic species makes this material safe for skin contact because silver fluoride can cause skin irritation and dermatotoxicity.
Okay, well, I think it's a very promising material, and your research, the entire research is very promising, has a lot of applications, is antimicrobial, as you mentioned, but not harmful for the humans and for the environment. So I really want to thank you for this nice interview, and I wish you all the best in the future with your research. Now I have some more questions for you regarding your career, your purchasing yourself. So you as a young chemist, I think you are perfectly suitable for giving advice to the next generation. So which advice would you give for this at the moment for young chemists in general?
Well, we all know that studying chemistry is not the easiest things to do. We all had to face difficult exams, strict professors, and so on. I would just say, just don't give up and follow your dream to become a scientist. This is what pushed me during hard times. I had many hard times, along with willing to get hands-on during lab trainings. I would also suggest choose a thesis project which is in line with your skills.
Yeah, thank you. I think these are very encouraging words to people who are studying chemistry now or planning to study chemistry in the future. What are your future goals in your career, actually?
Well, I really hope to continue my collaboration between the University of Bari here in Italy and Ulm University in Germany. as well as my research in the synthesis and characterization of non-antimicrobial. And thinking about the future, I really hope to continue in general my career in analytical chemistry here in my country.
And what advice would you give to students that are not sure in which field they should specialize?
Well, chemistry has lots of fields and topics. Just find the one which is right for you based on your own attitude. Try to think, for example, about which laboratory course was more comfortable for you. As an example, I felt like out of my element during the organic chemistry lab, so I immediately understood that that was not my way.
Okay, thank you. What is the advice? I think you were experienced enough as well to give some advice to PhD students that are starting their PhD, or the things they really need to focus on, or things that you may say from this is a bit less important.
Well, PhD life is really different from the one as a student, and when entering the research world, you may feel like confused and buried between deadlines and experimental plans. A detailed programming of experiments helped me a lot during the first year of my PhD school, and regular dialogue with my PhD supervisor was also extremely important to have a proper guide during the first stages of my scientific career. On the other hand, the last months before thesis defense were terribly hard, and that is the right moment, in my opinion, to start thinking about your future. So, looking for a postdoc position which allows you to expand your knowledge or further collaborations, or just find the right place out to the academia if you understand that that is not your world.
Okay, thank you very much, Chiara, for your inspiring words and for the advice we give to future PhD students, but also currently PhD students and students or postdoctoral researchers that are looking for other career opportunities in their research future. I wish you all the best in your future as well. Congratulations again with the Young Chemist Award. And I'm very happy that you wanted to join us this evening in this podcast. So thank you very much and all the best.
Thank you all. Good evening.
Hello everyone, it's Mark Lade here again. We hope you liked the first edition of our new series and stay tuned for the other 3 winners of the series. Please leave your feedback by rating our podcast, and if you have any questions or further remarks, you can also send us an email at podcasts@eycn.eu. Hear you soon!